Fluid mechanics is the branch of physics that studies fluid and the forces on them. These are divided by three groups: fluid statics, fluid kinematics, and fluid dynamics. Fluid statics is the study of fluid at rest. Fluid kinematics is the study of fluid in motion, and fluid dynamics is the study of the effect on forces on fluid motion. And we focus on fluid statics. The word statics is derived from the word staticus, or motionless, and fluid statics is called hydrostatics. What is an incompressible fluid? It is a fluid that is not reduced by volume when increasing pressure. And compressible fluid is a fluid that is reduced by volume when pressure is increased. Buoyancy. Buoyancy is an upward force exerted by a liquid, gas, or other fluid that opposes the weight of an immersed object. Now I'm going to discuss the types of flows. First one is laminar, next one is transitional, then last one is turbulent. As you can see here, the laminar flow. This is the pipe, and this is the flow of the fluid. So you can see the flow of the fluid is straight and it is parallel at the pipelines. Next is transitional flow. In transitional flow, there is a pattern. The fluid is going up and down. And the next one is the turbulent flow. In the turbulent, there is no pattern. The direction of the flow of the fluid is unknown. It's like it's being scattered. How to know if the flow is laminar or turbulent? Osborne-Reynolds is the one that conducted the experiment and finding how to get it and derive the formula, the Reynolds number. And this is dB rho over mu, or inside diameter times velocity times density over viscosity. If the answer is greater than 2100, the flow is turbulent, and if the Reynolds number is equal or less than 2100, then the flow is laminar. In the continuity equation, you can see mass in equals mass out, or the mass rate entering is equals to the mass rate going out. And you can see here M1 equals M2, and if we expand the formula equals B sub 1 times S sub 1 times rho sub 1 equals to B sub 2 times S sub 2 times rho sub 2. And there are other forms for the mass rate to get it, and here's the other one, because the mass rate times the mass velocity times area. The mass velocity is velocity times density, and the other one is M equals Q times rho, or the Q is the volumetric rate. How to get the volumetric rate is velocity times area. Now, I'm going to discuss the overall energy balance. And this is the OEB equation. Delta H plus delta E sub K plus delta E sub P equals Q plus W sub S. And if we expand the formula, it will be delta H plus delta B squared over 2GC alpha plus delta Z times G over GC equals Q plus W sub S. And if the flow is laminar, the alpha will be 0.5, and if it's turbulent, the alpha will be equals to 1. And in the shop work, since it's positive, if the given is turbine, the shock work will be positive, and if it's pump, the shock work will be negative. Now I'm going to discuss about the MEB, or the mechanical energy balance equation. Here's the equation. As you can see, there's a difference in the OEB. It is derived from the OEB, and delta H is equal to summation of F plus B times delta P plus Q. So if you transpose it, it will become like this, and if you expand furthermore, the formula will become like this. Now I'm going to discuss how to get the friction losses in pipes using friction factor F. Here is the Finance equation. FL equals 2 times F times B squared over GC times summation of L over D. FL is the friction, F sub L is the friction line, and F is the Finance friction factor, and the summation of L is the length, and D is the diameter. First, F is unknown, and the summation of L over D is unknown too. So to get the Finance friction factor, you need to get the Reynolds number. Then, if it's laminar, you need to divide it by you need to divide the 16 by the Reynolds number. Then, if it's turbulent, you need to get the formula from the handbook. And this in the laminar efficiency 16 over the Reynolds number, and in turbulent, this is the equation Churchill proved. And here is the given summation of L over D. If it's 45 degrees elbow, it's equals to 17, and it's 90 degrees elbow is equals to 35, and if it's T, it's equals to 50, and it's coupling, it equals to 2, then gate valve is equals to 9, then globe valve is equals to 300. Now you can solve the running friction factor, or the friction line. Not all the problems have the same pipe size. What if you are given different pipe size? For example, this is a compression. As you can see, in point 1, it is in the bigger diameter. You can see the diameter in the pipe is much more bigger. Then, and it flows at point 2, and it became smaller. To get it, you need the formula is FC equals KC times V2 squared over 2GC. Point 2 here is the smaller pipe. So here, how to get the KC is 0.55 times 1 minus D2 over D1 squared. So D2 is the smaller diameter. The other one is expansion. So you can see here, is it the pipe? They have different size, and here at point 1 it is smaller than, after going at point it became bigger, then that's why it's expansion. So the formula for this is here. The difference is not that much. In the K sub E, there's the difference there. So in this formula, D1 is the smaller diameter,